In this video, I'm going to show you how to determine the end behavior of a function using logic. So, first of all, end behavior is what happens to the function at the ends. In other words, what happens as x gets bigger and bigger and bigger, or as x gets smaller and smaller and smaller going to the left. So, the end behavior will always start off like this. As x approaches positive infinity, all right, f of x approaches, all right, that's what's happening on the right hand side. And then we'll say as x approaches negative infinity. And then we'll find out what happens on the left side of the function. So the thing that you need to understand is when you look at the terms in a polynomial. So I'm just looking at the numerator right now. It has two terms. We have x to the third power and 2x squared. Because of the exponents, these terms are not going to be growing at the same rate. The higher exponent is going to cause the first term to grow much, much, much faster than the second term. So as we approach infinity, the larger exponent term is going to be the only term that matters. Okay, so I'm going to highlight it. So only this term is going to matter the closer we get to infinity, because it's going to outpace the other term. Now we only have one term in the denominator, so that's going to matter. So that means the closer we get to infinity, okay, or negative infinity for that matter, this is going to get closer and closer to being the same as x to the third power over 3x to the third power. Now, just simplifying this down a little bit, this is the same thing as 1/3, because the x to the third powers cancel each other out and we get 1/3. That tells us that as x gets either really, really big or really, really small, because the x's are gone at this point, either way, it's going to approach 1/3. All right, let's look at another one. Start with the numerator. Which term has the highest exponent? This one does. So as we get closer and closer to infinity or negative infinity, only this term is going to matter. So we're going to ignore the other terms. The denominator only has one term, so that definitely matters. So as we go to the extremes, positive infinity or negative infinity, this function is going to get closer and closer to being whatever 4x to the fourth power over 8x squared is. We can just simplify this down. Let's see. So we're going to have negative 1, no, x to the fourth power over x squared. That's going to be x squared. So I'm going to have negative x squared. And then 4 over 8, this reduces down to like 1 over 2. But we don't really need the 1, do we? So I'm just going to put 2. All right, so this is what we're going to get closer and closer to. So now let's look at this and ask ourselves what will happen as x approaches infinity. We'll have to think about this because we still have an x in here. We still have to think about it some more. So as x approaches positive infinity, what happens to the function, the value of the function? Okay, so as x approaches infinity, that means x squared is going to approach infinity. So I'm going to have this big old infinity right here. Like this is going to be 1,000,000 and 1,000,000,000. But then don't forget about this negative sign in front. So this is going to take a billion and make it negative billion. If you divide that by 2, it's still going to be a very large number, a very large negative number. Okay, well, I guess technically like negative 1 million is technically a very, very, very small number. But when I say large and small in this context, I'm thinking of the absolute value. All right, so anyway, we're going to be approaching negative infinity, all right? Because we're going to have a really big number, but then it will be negative. So negative infinity. All right, similarly, what happens as x approaches negative infinity? Okay, is this going to flip to positive infinity now? Well, let's stop and think about that. Okay, so x is approaching negative infinity. That means we'll have negative 10, and then negative 100, negative 1,000, negative 1,000,000. So x is getting smaller and smaller and smaller, okay? It's getting more and more negative. X is going to be a really, I'm going to say this, technically this is incorrect for me to say it's a really big negative number, but I think you understand what I'm getting at. So this is going to be a really large negative number in here. All right? This is going to be a big negative number. But then when we square it, it's going to be a positive number. All right? You know, like, because if you have negative 100 and then you square it, that's going to give you a positive number. All right? So we're going to square it, and then that's going to give us a big positive number. Okay? But then we've got this negative sign still sitting there. So in the end, we're going to wind up with a big negative number again. Okay? So that's why in the end, this is going to be approaching negative infinity still. All right? So it's still going to be approaching negative infinity because we're still going to have a really big negative number in the end. All right, let's do that again. Which terms will matter? Only the highest exponent in the numerator and the highest exponent in the denominator. So as x approaches infinity or negative infinity, the function will approach 4x to the third power over 2x to the fourth power. And then this simplifies down, so this is going to be 2 over x. Now, what happens to this as x approaches infinity? All right, what happens to the value of the function? Well, as the denominator gets bigger and bigger and bigger, so this would be like 2 over 1,000,000, 2 over 1,000,000,000. That's going to be a teeny tiny number, all right? 2 divided by 1,000,000,000 is a really, really small number. But because we're talking about positive infinity, these are going to be really small positive numbers. Well, okay, as soon as I'm saying really, 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 really small, I'm talking about approaching 0. So yeah, technically they're positive, but it's approaching 0. So the positive aspect of it doesn't really matter right now. Now, what happens as x approaches negative infinity? All right, so the denominator is getting bigger and bigger and bigger, or I should say it's getting smaller and smaller and smaller, in the sense that this is going to be like negative 10, negative 100, negative 1,000, negative 1,000,000, negative 1,000,000,000. So the overall value is going to be getting smaller and smaller and smaller. It will be negative, but it's approaching 0 again, all right? As the denominator number gets larger in absolute value, the overall value of the function is going to get smaller. All right, one more. So no denominator to worry about this time. So we're only going to look at the first term that has the highest exponent. So as x approaches infinity or negative infinity, this is going to approach negative 2x to the third power. So what happens as x approaches infinity? All right, what happens to the value of the function? Well, as x gets bigger and bigger and bigger, I'm going to have a really huge number. It's going to be positive at first, but then when I multiply it by negative 2, it's going to become a really big negative number. So that's going to be negative infinity. All right, this part is going to be positive, but then times negative 2 makes it negative. All right, what happens as x approaches negative infinity? What happens to the value of the function? Okay, so in your mind, please understand that if you take a negative number and then you raise it to the third power, that still is going to give you a negative number, in this case, negative 27. So cubing something doesn't turn it positive, it stays negative. So as x gets closer and closer to negative infinity, so it's going to be a really big negative number. When you cube it, it's still going to be negative. So I'm going to have this is still going to be a really big old negative number right here. But then when you multiply by negative 2 times a negative number is going to equal a positive number. So in the end, we're going to have a really big positive number. So that's why it's going to be approaching positive infinity.